All right. Welcome everybody to Savas Algebra 2, lesson 3-4 here. Just getting started in this lesson, first problem. And we are supposed to find the quotient, which is the answer to a division problem, using long division. Now, normally I tell my classes, I don't really care if you use long division, but I will go ahead and explain it using long division here. Usually sets up looking like that. The divisor on the bottom, out in front, the dividend on top, what you're dividing into underneath here. And it just starts off asking yourself, 4a times what makes this first term, and 4 times 3, and a times a squared. I just line it up, the a squared's about, you don't have to do that. Then the next thing is, take just 3a squared times each of these to see how much we've made so far. If you, normal division, if you did like 3 into 13, and you said that's 4, 12, remainder of 1, just a reminder how this works. You take 3 times 4 plus this remainder thing down here, and it equals, it's under here. So far we've taken the 3a squared, and we have to multiply it by both of these divisors to see how much we've made, 3a times the 4a. If we've done everything right, these two, the leading term should always match up. And then the 3a squared times the 2, 6a squared, and line that up. That should be 6a squared under the a squareds. Now, I don't like to do subtraction because I make more mistakes. So I usually will say I'm going to change this to addition of the opposite. So 12a cubed plus a negative 12a cubed, those cancel. And then a negative 6a squared plus, remember I said, and that's why this is a good example. I've seen mistakes made a lot of times with this one. If it had been minus, they would have said those canceled. But negative 6a squared plus negative 6a squared is negative 12a squared. And then you still have all the rest of this too, if you want to bring it down so you don't forget it. That's not a bad idea. Then we move on. So we go to the next one. And we say this 4a times what makes this leading term, negative 12a squared. And hopefully you agree that's negative 3a. And then we multiply that times each of these to see how much we've made and see how much we still need after that when we subtract it away. Again, these leading terms here should always be the same because we're trying to get rid of them. Then 3a, negative 3a times 2, negative 6a. And again, I'm subtracting this. But if you want to add the opposite, again, for me, I'm less likely to make mistakes when I'm doing addition instead of subtracting in more negative signs. So negative 12a squared plus 12a squared, those cancel. Negative 2a squared plus 6a, that's 4a. And then I still have this 15 also. And now our last time we're going to do this. 4a times what to equal this 4a? 1. So multiplying that 1 times each of our divisors out here. That's 4a plus 2. This time I do think I can subtract them. I don't have any extra negatives in there to mess me up. The a's cancel. 15 minus 2 is 13, and that's my remainder. So the other thing with that is, if you remember when you're over here, when you had this remainder of 1, then you take that remainder of 1 and put it over your divisor. So your total answer was the 4 plus the 1 remainder over your divisor. So we're going to do something similar to that here. And what are we going to have? We got 3a to the second power minus 3a plus 1 plus our remainder, which was 13, over, what was our divisor? We were divided by 4a plus 2. And that's how you do long division. Hopefully that helps you out. If you need a little more help, don't forget down here at the bottom, you've got your view and example, help me solve this. Those give you some other ways other than this video to help figure out the problem. Keep after it, you can figure it out. Don't give up.